problem, correct? Yeah, they ask you to think, will you expect every bag of grapes to weigh exactly 1 kg? Hmm? Do you expect that?
No.
Please respond. Open response.
No.
No. Okay, so what is this person trying to do? When you talk about statistics, right? What is the problem? Okay, I think all of us have studied science before, correct? We have done experiment before, correct? Every time when you want to carry out experiment, why must you carry out experiment? Nick? Nick? Shazana?
Yes.
Why we need to carry out experiment?
To gather the information we get. Experiment.
Yeah? Yes? I can't hear you. Can you speak a bit louder?
To gather the information we get.
Okay. Example, you give me? You say to get information, correct? So you give me example.
Like the outcome for
Okay, what do you mean by the outcome?
the end product of.
Okay, the end product. You don't know how. Okay, can you carry out experiment? Can you carry out an experiment just based on the outcome?
Cannot.
You won't have the outcome, correct? Because you don't know what you want to find. So how you start an experiment? Thaddeus?
We plan the experiment first.
Huh?
Plan the
Thaddeus,
experiment
louder,
first.
please. You plan the experiment first. How are you going to plan an experiment before you know what to do? What experiment are you going to plan? So you see the order of your carry out the experiment is wrong already. From young. You never ask your teacher, why must I carry out this experiment?
Miss, is it we make up a hypothesis
Why you want to make a hypothesis?
to ask a question and do experiment to conclude something?
Someone have texted in the chat. Can that person speak it out?
Identify problem.
Yes. So if you want to talk about what is statistic and what is scientific experiment is scientific method is you learn it in form 1. Scientific method, correct? Start first, identify the problem. So you must first start with the problem. I must ask myself, what problem do I want to solve? What do I want to solve? What problem do I need to solve? So you start with a problem, identify the problem. So in this case, statistics is a scientific method, but it's very different from the one we do in science, because when you talk about science, You have to go to the lab and carry out the experiment. Statistic, you don't carry out the experiment, is you carry out is what? First, you identify the problem. So what do I need to solve here? So in this case, the opening problem, what are the problem? What is the problem that you want to solve? Can someone tell me? Kavan? You please listen carefully, because this you are going to write your folio in this way as well. You have a problem to solve. So you have to know how to identify your problem. This is a problem of society. Are you sure? Our opening problem in page 154. Hello? Kevin? Mental problem. What's our mental problem you have? Opening problem, you say, would you expect every bag of grapes to weigh exactly 1 kg? How to?
Hello, yes.
Yes. What is the problem?
To know if the grape is 1 kg or not, or
The grapes are.
the grape bag of grapes.
So is every bag of grapes weigh 1 kg? So that is your problem. You want to know. So if you want to know this problem, correct? So first, what problem do you want to solve? So usually when we say problem, we always ask in a question form. Is every bag of grape sold? So you have to identify you want to talk about where? Is every bag of grapes sold in supermarket A? Weigh exactly or weigh 1 kg. Or I can even, if I don't want, I can even make my problem like that. Weigh more than, is every bag of grapes. I can make it more precise. Label as 1 kg. Sold in supermarket A, weigh more than 1 kg. So you see, in this situation, when I state my problem, this is called your problem statement. In statistics, this is called your problem statement. So your problem statement include what? Is it any bag of grapes? No, you very specific. Label as 1 kg. And where is your population? Supermarket A. All the bags of grapes labeled as 1 kg sold in your supermarket, that is your population. That is the problem that you want to solve. So what is population? The entire collection of individuals about which we want to draw conclusion. So this is called your population. All the bags of grapes that is sold in supermarket A, but is it all? Those labeled as 1 kg. So that is called your population. So in your problem statement, you should state your population. So every time when you do something, you should know what is your population. The entire collection of individuals about which we want to draw conclusion. What conclusion we want to draw? We want to draw whether it is more than 1 kg or not. So that is a population. So population can be very big, can be very small. So in this case, the population, if my problem statement is every bag of grapes labeled as 1 kg sold in supermarket A weigh more than 1 kg. So my population will be all the bags of grapes labeled as 1 kg sold in supermarket A. So it can be anytime. Are you clear? So you have to specify your population. So now you understand the meaning of the word population. So every time before you talk about population, before you talk about data, you must first have your, what you so-called in statistics, we call it problem statement. Are you okay? So I changed a little bit. Yeah. Or your problem statement can be from part B. In what range of weight will you expect most of the grapes of bags of grapes is like? So this one we will learn in chapter 9. We call it, how are we going to predict? You get me? So this is what you call statistic. You must start with a problem statement. Okay, science also you start with problem statement. So from the problem statement, you know your population. Are you clear? You know your population. Okay, now, after you got your problem statement, in science also, you got a problem statement. Then after that, you go into talking about the relationship. The relationship between certain things, correct? That is in science. Like for example, you carry out an experiment about a pendulum. So you have to have a hypothesis. So in statistics, hypothesis is called our claim. So you may not see this word. You will see this word in chapter 9. So I have to give you the picture of statistic as a whole, the claim. So I can say I can make a claim like that based on the statement in opening problem in part B. I can make a claim like that. The mean weight of a bag of 1 kg grapes from supermarket A. Or I can say the manager claimed that. Okay, so that is the claim. Okay, supermarket A is more than 0.9 kg. Okay? So this is the claim. You have the claim already, then only you can do what? You can know what to collect. So what are you going to collect? You want to collect mean weight. So what do you mean by mean weight? So from here, you can start to collect data. So this is where in science, you get into the experiment. You plan your experiment. So now you plan how to collect data. You see? So how to plan, how to collect data. Okay, so now you have the data is information about the characteristic of a group of individual. Okay, now what characteristic I'm interested in here? I'm interested in mean weight. So that is the characteristic that I'm talking about. I define my population already. I define my hypothesis already. So now I can plan how to collect data. I want to collect the mean weight. So when you talk about how to collect the mean weight, mean, well, what do you mean by mean? So all this is, and parameter, you look, you see parameter, a numerical quantity measuring some aspect of the population. So what aspect of the population I'm interested in this case? I'm talking about the weight of 1 kg of grapes, the mean weight. So you have to define your parameter. So it's exactly like that. In science, you talk about manipulated variable, responding variable, am I right? Constant variable. So in statistics, you're talking about the parameter. What do you want to collect? What do you want to study? So you have to specify your parameter clearly. In this case, I'm talking about the mean weight. So how am I going to collect mean weight? So I have to collect. Is it possible for me every day sit at the supermarket there and go and collect and study the entire population? It's impossible. The entire population is very, very big. So what I need to do? I need to do sampling. So this is exactly like in science experiment. Can you study every case? No, you study certain cases. Correct? Like in science, you study certain cases, then you plot the graph and so on and so forth. So in statistics, you take sampling. We so-called sample. Do you see the word sample? A subset of the population which should be chosen at random. Okay, so what do you mean by a random sample? A random sample, that means everyone in the population will have an equal chance to be selected as part of the sample. No bias. That is called random. So your sample must be random so that your conclusion will be no bias. So all these words we will go into detail later. So after we collect the data ID, then we have to do some calculation. So that is what you call statistic. A quantity calculated from the data gathered from a sample, usually used to estimate the population parameter. So the parameter I want to estimate is here. the mean weight. So the distribution outlier, all this we are going to talk about. So what is statistic? Statistic is a scientific method that help us to solve a problem. So what is statistical procedure? You start with a problem statement. In your problem statement, you should identify your parameter. You identify your population. After you have your population problem statement, then before you collect your data, you must have a claim. Someone say something, someone claim something, and your claim must involve the parameter in your problem statement. After that, you have the claim, then you plan how to collect the data. So you can do survey, you can do whatsoever. And when we collect data, we collect the sample data. It's impossible for you to study the whole population because in actual situation, the whole population is very big. So if you want to study the whole population, it's going to be very time consuming and it's going to be take you a long time. So the result that come out maybe after 1 year or 2 years. That is exactly what happened to COVID-19. You can't chase the data, you can't chase after the mutation of the virus. You come up with the vaccine, you see another new strain coming in. So you can't chase. So when you talk about COVID-19, vaccination is not a way to prevent COVID-19. No way. Because virus mutate much faster than you can come up with the solution. So that's why we use sampling. Okay, when you talk about sampling, you collect the data. Later, we will study what type distribution and so on and so forth. So from the data, from the how we are going to use the data to do certain calculation, that will be in chapter 7, 8, and 9. And the most important one is chapter 9 later on. Are you clear? So from there, from the value we get, from the concept we learn, from how are we going to interpret the value, that will help us to make the conclusion, whether the claim is justified or not justified. So in statistics, we don't call it hypothesis, we call it claim. So you carry out, we don't call it experiment, we call collection of data, calculation of the value. Okay? How to calculate? In science, you plot graph. In statistics, you find different things. You find mean, you find standard deviation, then you must know how to interpret them. So whatever you learn in high school, please take note, whatever you learn in high school is just the calculation part of statistics. You haven't gone into actual statistics. You don't even interpret the value. So I told some of your friends that if statistic is this long, the knowledge of statistics is this long. I only know not even one dot. So you can imagine the knowledge of statistics is a lot. A lot. So why we need to know how the data distribution like? Because that will help us to interpret. When people give you certain value, then how it go. That one, I will talk about it later in chapter 7 and 8. Are you okay? So now you have the idea. So please bear whatever we discussed today in mind here, because you are going to write your folio based on that. You must have a problem statement. You must tell people what you want to know. What problem do you want to solve? In your problem statement, you must state clearly what is the parameter, where is the population, how big is the population. Then you zoom into specifically what do you want to know exactly about the population. Is based on someone say something. Like for example, someone about COVID-19, correct? Someone said that Omicron death rate now have exceeded Delta death rate. So how are you going to collect data? So this is talking about okay, when you talk about all this, these are very big topic. These are very big topic. Understand? So when you come to your folio writing, I will tell you what are the suitable topic for you, so that you can show your understanding of what statistics all about. Try not to choose a very big topic, very huge topic, very fantastic topic, whereby you find it difficult to show your understanding of statistics. Hello? So now you know what is statistics all about. You want to solve a problem. If you want to solve a problem, you must know what the problem is. And you must know how to solve the problem. Can or not? Okay. So any question before I go further? Can anyone answer opening problem part D? Can anyone answer the opening problem part D? Will the grape look different if we will analyze the weight of 1 kg bags of sugar? Can anyone answer that? Shinchi?
Yes.
Shinchi, can you try to answer?
Yes, yes.
Can you try to answer part D? Problem, the problem, opening problem on page 154.
Yes.
Well, how would the difference be? Okay, if I give you W1, Okay, and I give you W2. Okay, you tell me which one is grapes, which one is sugar. A bag of sugar, a bag of grape. W1 or W2?
W2.
W2 is which one?
Sugar.
Sugar. Okay, now you tell me why. Why you choose W2 for sugar and why you choose W1 for grapes?
Because sugar is like smaller particles, so the range of the weight should be smaller.
Okay. Another person? Ishan?
Because sugar smaller and harder to like
Other
count.
than that? Other than that?
I'm not sure.
Hey, think lah.
Grapes easier to like collect.
Grapes is easier to collect.
Yeah, like easier to like they grow. I don't know.
To grow. Okay. Chunyi? I want to hear from you. Chunyi?
Actually, no, teacher.
Huh? Who packed the sugar? Yeah, the size of the particle is smaller, but if all packed by human, do you think it will be the same?
No.
Okay, so there's another reason. Machine packed, correct? Grapes, because the size of the grapes vary a lot, so you can't get the exact 1 kg, correct? And usually grapes is, you can't control the size even it's machine packed, correct? So that means which one is more precise? Which one is more precise? You know the meaning of the precision, correct? Which one is more precise? Jen Hao.
Very more precise.
Grapes more precise. The weight of one bag of grapes
No,
more
sugar,
precise.
sugar.
Sugar. Which one have a greater spread? Jen Hao.
Spread.
Spread.
Grape.
The grapes. So do you know why you need to count standard deviation? So these are all the things that we are going to learn later. That is how you interpret the value. So please, from now onward, everyone bear in mind, statistic is not just the number. You have to know why you calculate the number, why you need to know the number, and so on. Okay, so how do you organize data? Can you please go to page 155? All that I will leave it to you because you have learned it already. Numerical variable. Okay. Hello? Can you please go to 155? Discrete. So now you have all this already, correct? So now you want to plan. You have to know the variable. So the variable that you are going to talk about is the weight of a bag of Okay, so that is called the variable. It can vary. We have two types of variable. We have two types of variable. If you go to page 155, yeah. So what are the variables? Two types of variable. So from here, we know our variable. So can you tell me what type of variables are they? Two types.
The number of people in the car.
No, I'm talking about page 155.
Yeah,
You go to page 155. We talk about variable, numerical variable.
that's right. The height
Where,
of year 12 students.
numerical variables. When you say numerical means involve numbers. Because you have another one called categorical variable, correct? That is go by category, like types of car and so on. That one is not important to me. So I want to know numerical variables, that means involve numbers. So numbers. So you got two types of numerical variables. Okay. So what are they? Azif?
Yes, yes.
Yeah. What are the two types of numerical variable on page 155?
Discrete numerical variable
Yeah, discrete.
and
And under
continuous.
the discrete, they come with the word what?
Counting.
So it's countable. So please, this one we will link to chapter 7. That is, if you go to chapter 7, that will go under binomial distribution. That's chapter 7. Okay, so it's countable. You can count using your finger 1, 2, 3, 4, 5. That means this value involve whole, the variable involve whole numbers. Are you clear? Okay, so what is another type of variable, Bram? Bram, are you in the class?
A continuous numerical variable.
Yeah, so we say continuous variable. Okay, when you talk about continuous variable, you are talking about, Bram, result of what?
Measuring.
So we call it measurable. So that means this variable will take any whole number, any real number. Okay, any real positive number. It can be decimal, it can be the one. So the distribution will be what we are going to study in chapter 8. So now you understand? So do you know the whole scope? Then chapter 9 will be the one that how we draw conclusion. That is your confidence interval. So you see, this whole statistic from chapter 6 to chapter 9, everything is connected. You cannot run away. Okay, organizing data, you can organize in any way you like. You can have table, you can have pie chart, you can have bar chart, you can have a lot of things. Yep. So that one, I will leave it to you. So the case study there. Yep. So tomorrow we will do exercise 6A. So now I will leave to you how to do it. You can go to your graphic calculator. Everyone, go to your graphic calculator and explore this button. GC, go and explore this button stack. If you press this button stack, you will come out with edit, calculate, and test. Test will under chapter 9. Calculate will be chapter 6. Okay. Edit also under chapter 6. So there is one part for chapter 7 and chapter 8 under your GC is you go to, I let you know everything as a whole. You go and explore your GC today. You go to second verse. There is a distribution up here, correct? So I told you, this is binomial distribution, this is normal distribution. So you go there, you have a look, then you can get everything. So you go and study about that. So in this, everything about statistics, we all use our graphic calculator to do calculation. We don't do it manually. Clear? Okay, so I'm telling you, tomorrow I'm going to talk about exercise 6A. So all this whole week are revision. All this you have learned it in your high school before. Okay, will I test you on that? I'm telling you, no, but you may need some of it in your writing of your folio. Clear? Okay. So done with that. So I give you the whole picture of statistics today. Statistics, you must look it as a whole. Don't look it as an individual. You will know how to link it. Maybe some of the word that I mentioned to you is like an alien to you. Never mind. As we move along, at least you have heard it before, then you know how to link it later on. Clear? Okay, thank you, class.
Miss.
Thank you.